Statistics. We're going to calculate a couple of correlations today and then talk about some properties of correlation today. That's the crazy formula. I'll write it up here at the top. R equals 1 over n minus 1 times the sum for I equals 1 to n of the product of z-scores, x sub I minus x bar over the standard deviation of x, and y sub I minus y bar over the standard deviation of y. Oh man, is that intimidating looking, right? Well, look, I've got a small amount of points for us to deal with here. First thing we're going to do is turn these into a scatter plot where the east side points are 5, 0, 8, 4, 1, 2, and 2, 6. So I'm going to put one at 5, 0, put a point right there, and 8, 4. So there's a 8, 4, and then 1, 2, and then 2, 6. So not an extraordinary scatter plot. The west side points, I have no idea what this data is for. So it's 2 and then 1, 5 and then 2, 7 and then 2, and 6, and then up to 3. Okay, so there are my two scatter plots. I could see this being a linear form, and I could see this being a linear form, even though there's only 4 points. Here's the directions. Calculate the correlation for your data set. Well, if I really wanted to do that, I would go to my calculator, and I would, whoopsie, I don't know how I got to there. Let's just go back to the home base here. I would put these data values in list 1 and list 2. So I'm going to hit stat and edit. I've got stuff in my list, so I'm going to go up, hit clear, go down, go up, hit clear, go down. And I'm going to put both of these in. So 5, 8, 1, and 2. And in the next one, I'm going to go 0, 4. These have to be in the same order because they're ordered pairs. Let's not forget that. Okay, then I'm going to hit stat. I'm going to go over to calc, and I'm going to do one variable statistics, number 1 right there, so that for list 1, so I can get some really important stuff. So I put that as list 1 and hit calculate. And here's what I get. I'm going to write these down here. I'm going to divide this in, oops, that moved on me. I'm going to divide this into 2 so I can do the correlation for both of these. Looks to me like this one will be stronger, by the way, and definitely positive, and this one will be weaker and negative. Okay, my x bar is equal to 4. My standard deviation of x is 3.2. I also need from list 2 this stuff. So I'm going to hit stat, go over to calc. I'm going to do one variable statistics, but this time for list 2, those are my y values. So this tells me x bar, but it's really y bar is equal to 3 and s sub y is equal to 2.6. And n, of course, is equal to 4 because there are 4 ordered pairs. Now I'm supposed to calculate the correlation. It's a little easier to do when there's only 4 points. So here we go. It's going to be r equals 1 over 4 minus 1. So it's just 1/3, right? And then here's what happens. We find the z-score for every point. So go to the x up there. The first one is 5. It will go 5 minus its mean, 4, over its standard deviation, 3.2. That will get multiplied by the z-score of the y value. So the y value is 0. So I go 0 minus its mean, 3, over its standard deviation, 2.6. There's my first pair of numbers. Let's get my second one in here. That's the point 8, 4. So I'm going to go 8 minus the mean of the x's, which is 4, over the standard deviation of the x's, which is 3.2. Then I'm going to multiply that times my y value for that point is 4, so it would be 4 minus the mean of the y's, which is 3, and the standard deviation of the y's, which is 2.6. I've got to add 2 more of these, so I'm going to do a little wrap text kind of thing. And then the next one will be the point 1, 2. So I go 1 minus the mean of the x's, which is 4, over the standard deviation of x's, which is 3.2. And then I go 2 minus the mean of the y's, which is 3, over the standard deviation of y's, which is 2.6. And then I have one more point to do, 2, 6. So I'm going to go 2 minus the mean of x's, which is 4, over the standard deviation of x's, which is 3.2. And the last y value is 6, so it goes 6 minus 3, which is the mean of the y's, over 2.6, which is the standard deviation of the y's. Now, all of that's got to go in the calculator. I can skip a little bit of it. Watch. 5 minus 4 is 1. I have 1 divided by 3.2 times negative 3 divided by 2.6. Then I'm going to hit a plus. Then I'm going to say 8 minus 4 is 4 divided by 3.2. And we'll go, that's going to be times 1 divided by 2.6. Close my parentheses. I'm going to hit another plus. Then down here I have negative 3, I'll open parentheses again. Negative 3 divided by 3.2. And that's going to be times 2 minus 1 is negative 1 divided by 2.6. Close those parentheses. Then I'm going to hit plus one more time. And I have parentheses negative 2 divided by 3.2, and it'll be times 3 divided by 2.6. Okay, I put all of that in, and I get a grand total of negative 0.24. So this is R is equal to 1/3 times negative 0.24. So put that in the calculator, or divide by 3. Isn't that dividing by 3? So I'm going to take my answer and divide it by 3. And what I get here is R is equal to negative 0.08. That is a very weak linear form. And look at it. You can see it's negative, but it is definitely really weak. That's how weak it is. Okay, so for the second one, I want you guys to try it. I have 1, 2, 3. There's 4 data values, so it'll start out as R equals 1/3. We don't have to write the 4 minus 1. I think you guys get that. Then you need to write out 4 different pairs of numbers being multiplied together, the z-scores, and then see if you can get the right answer. Do that now.